In a factory that produces wire, a spooling machine is programmed to put 3,200 feet of wire on each spool. So the company ran the machine multiple times and recorded how much wire was actually placed on each spool, and they found that the mean length was 3,220 and a standard deviation was 20 feet. So they ran the machine again to produce an additional sample of 400 spools. Okay, so that's a lot of information, but we were given enough to make our normal distribution. So our mean length, that's the middle, was 3,220. So how many spools have at least 3,220? Well, this is where the normal distribution cuts in half. So that's 50% have at least that. And now we have to go look at our sample. So our sample's 400 and we want 50% of that. So 50% of 400 is half of 400, which is 200. So that one is good. Okay, now we have some other numbers here, 3,200, 3,240. So now we're going to use our standard deviation of 20. So we're going to add 20 to go to 3,240, and we could keep going. It'd be 3,260, 3,280, and then you're subtracting 20 the other way. So 3,200, 3,180, 3,160. So this is saying how many spools have less than 3,200. So this part. I'm going to draw it up here so I can erase it. So this is half, and this is 34%. So 50 plus 34. So this whole section is 84%. The whole graph is 100. So that means that 16% is less than 3,200. So now I want 16% of the sample, which is 400. So 16% of 400 is 64. Okay, next one. How many spools have between 3,200 and 3,240? So now I'm going to shade. So from here to here. And we're using this rule. This is 68% of the sample. 34 and 34. That's the rule that they're mentioning. So 68% are between those two numbers. 68 of 400 is 272 are between those two numbers.